Let's start. So, today I propose to you to continue working on the design of the database, and then on top of that, we'll of course build the database for real, and then try to build like follow all of the steps until the front end, so that we build the DAO, then we build the Flask, and then we build the functionalities on the front end, so that you can have like a whole perspective of what the implementation means technically. Okay, so let's start again with this. So yesterday we, yesterday we got here. Okay, so yesterday basically we achieved this diagram. Basically we defined the entities and we also defined the cardinality among these entities. Now though, we have to identify which are going to be the specific attributes for each entity. Okay, so which are going to be then the columns of the tables that will represent each entity. So let's very quickly get back here and try to identify for each one of them which data do we want to represent, okay? Okay, so there is data that is super explicit here and is data concerning the entity itself. And then we will see that we will also have fields or data that had to do with the foreign keys, with the primary keys, and with more operational data that enables us to create the relationships. So let's get to the user. So which attributes does the user have? Okay, of course we will have the ID, that is an integer and will be the primary key. Then from here we can see that he has first name and last name. So question, these attributes, which characteristic they will have? Can they be null? No. We would be expecting the user to be mandatory to insert the name and the last name, okay? So in this case, we will say this will be not null. What else? The email. This one is also text and we are expecting it to be not null. Then we have the password. Okay. We decided yesterday that we will represent the tutor and the student as the same entity or by using one single entity. But I was thinking, the issue with that approach is that, for instance, if the user is just a student, what will happen with this data that makes just sense if he is a tutor? I mean, we could add all of these attributes here, but in case that a user is just a student, all of this data will stay empty, no? All of this data won't make sense for some users. This data will make sense just for the ones that are tutors. So how do you think we might solve this? Yeah, they can be in that case, of course. But what I don't like about this approach is that if we take a look at the database, at the table, we will see a lot of empty fields, no? Because for all of that users that are just students and not tutors, all of this information will remain empty. Yeah?
We can create a foreign table with this information, and with a field in the table user, we can indicate if the user is a tutor or not, and if yes, we can take the primary key of the user and
Yeah.
put it like a foreign key in the other table.
Yeah, I'm thinking something like that. But in that case, if we have two tables, for instance, user and tutor, or student and tutor, what would be the relation, the cardinality of the relation between them? Many to many, one to one?
I think many to many, because there is the lesson table between them, and there is one student for many lessons.
No, but in that case, it's for the lessons. But I mean, because yeah, now the approach is we try to split the user into two tables, no? One of them for representing the students, and one of them for representing the tutors. That is something similar to what we were doing yesterday. And we are taking that approach because we don't want into a single table all of these fields to remain empty. Okay? So the question is the relation between a user and a tutor, how would that relation be? What's the cardinality in that relation?
The user is just a student.
Yeah. And the tutor?
So one student has multiple tutors, and one tutor has multiple students. So it's
Let me show you this, because maybe I'm not. Okay, let's keep the user and let's try to do the tutors. Indeed, here is users, and then here are the tutors. So the tutors have all of this information that we have defined here, right? Which is all of the personal information. But other than that, he has other data. The subjects or skills taught, it has that information, but we can't represent that information through a single attribute, but we have to represent the subjects that he is linked to by means of a relationship, okay? So we won't still define it through a single attribute. So for now, we will say he will have the ID. That is a primary key. Then he has, okay, the personal information. He has a bio. That is a text, and we will say it's not null. The availability for lessons is something that we can represent here through a single attribute, or is something that we will have to represent with respect or in relation to the association between the tutor and the lessons. I think it's something that concerns the relation between the tutor and the lessons, no? It's not information that belongs to a specific user, the availability, but it makes sense to say that for a specific lesson that the tutor teach, he has a specific availability, okay? So here we don't represent that availability for lessons as an attribute or as information belonging to the tutor, but it's information belonging to the relation between the tutor and the lessons that he teach. So in this case, it's not possible to represent it with an attribute. What about the lesson format? Is information that belongs, that we can represent associated to the tutor, or is information associated to the relation with the tutor and the lessons? Yeah, because it makes sense to say this tutor for this lesson, the lesson format is online, or this tutor for this lesson, his lesson format is in presence or Google. And what about the rate, the price of the lesson? Is information that belongs to the user, or do you think it is information that belongs to a relation of the user with the lessons? It depends. We might say that the tutor has to ask the same price for all of the lessons that he will teach, or that he can set different prices depending on the lesson and on the subject he will teach. Which one do we like, or which one do we find more reasonable? I think it should depend, no? Maybe one subject or one kind of lesson is easier, and he might be willing to get less money than another lesson that is more difficult and complex, and he might have a different rate. Okay, so in this case, if you agree, I would say that this hourly rate attribute is not necessarily linked to the tutor, but to the relation between the tutor and a specific lesson. Okay. So what I was saying before, what I was trying to explain between the relation between these two entities and the relation between these two entities is that we might do something like this, okay? The tutor, one tutor might be linked or might be associated with one user. Why is that? Because the tutor is at the end a user, and he will have all of the data that we have defined for the users. All of these data apply for a tutor. Do we agree? It is just that other from this data, he will also have a bio, and he will also have some other attributes that we haven't identified so far. So to make this distinction between a regular user or the student and the additional data that a tutor might have and the additional relationships that a tutor might have, we can split it into another table. In this case, if we follow this approach, how do you think the cardinality will be between a tutor and a user? It's 1-to-1, no? At the end, it's like, well, I don't know if this is completely clear, but at the end, it's like if okay, let's suppose that I register on the platform. So it has, as soon as I register, I have to complete all of this information, fulfill all of this information. So it will have my name, Juan Sáenz, Juan.Sáenz Lapolito, and my password, 12345. Okay, so up to that point, I am a registered user in the platform. Then what happens? How I imagine this is that I want to say, or I want to register, or I want to register in the platform also as a tutor. So what will happen when I want to register as a tutor? The platform will ask me, okay, so if you want to become a tutor, please complete other than, I already have your information as a user, but since you want to become also a tutor, please give me your bio and give me other data, okay? So in that case, the way of managing that data or managing that information is by creating a new row in a different table and associating that row and that specific information that I have as a tutor to my information, my previous information that I had as a user. Is it clear? And the correspondence in that case will be 1-to-1, okay? So since Juan here, that is the user 0, is registering also as a tutor, the foreign key here will be pointing to the user 0. And in this case, it's like having all of the information, all of the data from a specific user, not in a single row, but in a row split between two tables. What am I achieving in that case? I'm achieving in this case that if, for instance, I would have set all of these attributes in the users table, for all of the users who don't want to become a tutor, these attributes would be empty, okay? So instead of having empty attributes, I make sure that I created them in another table, and in that another table, all of those attributes will be complete for the users that will be, for the tutors that will be registered there. Yeah?
So you're saying that if a user is a tutor, a tutor must be also a student.
Must be also a user, yeah.
So we're going to create another table for the students, or
But it might be an option if the student have different attributes. Okay?
now
Because right now we can, I mean, from the text, we can say that the attributes that represent a student are the ones that are already in the users table.
okay, so
If there were like a special attributes or a set of special attributes that just the students have, it would make sense to create another table with that specific attributes.
okay, so now it's impossible for a tutor to be just a tutor, because otherwise we wouldn't have, for example, the name.
It would be impossible for a tutor to be just a tutor. No, indeed, he's just a tutor. Because that information for the users is for all of the users. Even if you are a student or if you are, this is like an abstraction. So there is common data that is common for each user, that is mandatory for each user that wants to use the platform. By default, a user that wants to use the platform is a student, let's say. And on top of that, additionally, he might become a tutor. In the case he wants to become a tutor, he has also to provide me that information that I'm asking below. Okay? But yeah, in your case, if we identify that there is information belonging just to the users that are students, then it would make sense to create another table, and in that another table representing the attributes that are just for the students. So at the end here, this is like a generalization class. If we were thinking of classes, this is like a generalization. We are representing all of the common attributes in the users table, and then we are doing two more tables, one or two more tables, in this case one, to represent the specific attributes. Okay, I'm coming, yeah.
I was thinking, why don't we use basic inheritance in SQL? So, like a users table with a type column, and then users can be tutors or students.
Yeah.
And based on what's in the type type column, then some
Attributes.
are filled and some aren't.
Sure, I agree. But in that case, you are saying that all of the data would be in the same table, right?
Yes.
Just one table for representing everything.
For users.
Yeah, that was the original design that we had before, but what I don't like about that design is that there would remain a lot of fields empty. No, because for instance, if he's just a student or if he's not a tutor, all of the data that belongs or that is represented when a user is a tutor would remain empty. Okay? In this case, indeed, we have the opposite. We have all of the, if he's a tutor, he will have his data into a different structure with it complete. So far, we have just identified the view, okay? Because we haven't already added the relationships. But when we will work on the primary keys and the foreign keys to make the relationships, we will see that this tutors table will have more data, more fields, okay? So I don't want neither to create a relationship between a user, a regular user, and a lesson, because that relationship might not exist if he's not a tutor, for instance. Yeah.
It's similar to the last question, but is it possible to give a parent-child relationship between the user as the parent and the tutor or students as the child?
Yeah, it's somehow what we are building here. Because, let me. Somehow is what we're building here, because if we think this of a specific Because, well, I'm giving just an example to make this super clear. If I am a user and I register the platform for the first time, I would set this data, no? The name, the email, and the password. And here, in this case, when I register for the first time, I'm just a user and I will have the ID 0, okay? Let's suppose that at some point I want to become a tutor in the platform, or I want to propose myself as a tutor. What will happen in that case when I propose myself as a tutor? The platform will ask me to complete the information that is just exclusively or belongs to a tutor, okay? So in this case, I would also be creating a new row in the tutors table that would be the ID 0, the bio, that is, okay, hello. And here is the most important part, that is the foreign key, that would be 0. So somehow, what I'm doing here is associating this row with this row. You know what I mean? What would happen if a different user registers and he's not interested in to be a tutor? He would be the user 1 with the name, okay. And in this case, what would happen? There will be no row in the tutors table referencing him. So he just provided the information for the basic registration as a regular user. That in our case, we say that a regular user is a student by default. You know what I mean? So somehow this is such kind of approach in which we have like a parent or the commonalities or the common attributes among all of the possible users, and we have the specialization in the case that the user might have a specific role. Okay? Is this clear? Is this approach super clear? Is it clear why we took this design decision? Okay. Okay, the other one was subject. As usual, we set the ID, that is an integer, that is the primary key. What information do you think we might associate to a subject? Of course, the name. What else can we set associated? Does it come to you something else we can? The description. Yeah, why not? Some kind of description. Is this description mandatory or optional? Maybe optional. So okay, let's keep it not null, but optional. But what else we can say about a subject?
Statistics.
The?
Statistics. Exam passing statistics.
Okay, being the statistics, what?
Rate of passing. Passing exam.
Yeah, but yeah, that would make sense if we were thinking, for instance, in the Polito database, because we might have that data for the students. But in this case, that is just a single tutor offering that subject. How can he determine I mean, it doesn't exist like the passing condition here. It's just, for instance, me offering to do tutoring on informatics, so, on web applications. So well, in this case, I would say that one wouldn't count. But do you have something else that might come to your mind, the subject? Okay. And then we have lessons, right? Yeah. Okay. Okay. Okay, so right now we have something like this. What can we say about the lessons? What information can we associate with the lessons, for instance? For instance, the price is something that we can associate with the lessons, with a lesson. Yeah. Yeah. How do we represent the time in this case?
Well, either as a int, or maybe there is a.
Yeah, you mean that like the data type, right?
Yeah.
Yeah, but other than the data type, first of all, which attributes are going to represent as the time?
Well, either both started and.
I agree with time, like starting time and end time. So a specific lesson will have starting time. Is it not null? I would say yes, because well, this is information that is kind of mandatory. And okay. What else? Okay, so for now, let's keep these ones. And now let's try to do something more difficult that is try to relate these separate entities that we have identified so far. So how would they interact and how would they interact? So for up to now we already have one relationship, that is this one, the ID user foreign key with this one. Okay? So here between these two entities, we already have a one-to-one relationship. Do we all agree? Is it clear that these two entities are related one-to-one? Okay. Then what's the relation between the subjects and the users? Are they related? The subjects, the users and the subjects? No, because a student is not directly related to a specific subject. Instead of that, is the tutor related to the subject? Okay. I'm honestly asking this as a question because it's something that we have to figure out all together. Are we going to have a relation between the tutors and the subjects? Or are we going to have a relation from the tutors to the lessons and the lesson be related to a subject? The second, right? Do we all agree that the second makes more sense? It is not a tutor that is related to a subject, but it's the tutor who offers lessons on a specific subject. Okay? And anyway, if we have the information represented in this way, we will be able to set a list, for instance, of the subjects that a specific tutor is associated to, because anyway we'll have the way to figure out in this schema which subjects are taught by the user. So I think I would say that the relation would be in this way, okay? And somehow this lessons table is the table that bounds the subjects and the tutors. So it's more or less like the intermediate table that we saw yesterday that help us to represent a many-to-many relationship. Because one tutor might be teaching several subjects and several subjects might be taught by different tutors, okay? So somehow this lessons table is the one that makes the association between the two entities, okay? Let me see. Let me know if you agree with this. If here in tutors, in lessons, I'm sorry, I said ID Okay, does this make sense? That a lesson is taught by a specific user and on a specific subject, okay? Is that what I'm trying to represent through those two attributes that I set there So a lesson is associated to a specific subject and is taught by a specific tutor. Does it work?
Yes.
I think it works, right? Okay, I think it works. Maybe what I just want to highlight is that here in this schema there are several decisions that we are making, no? So for instance, we are saying that one lesson is only related to one subject. So there might not be a lesson in which different subjects are taught, for instance. We're also saying that one lesson involves just one tutor, okay? So there might not be 3 tutors working on the same lesson, but it's one-to-one relationship. That it's fine. If our requirements and if what we want to build and our application to work and to behave, we agree with that specifications, it's completely fine. It is just to say that each time that we design something, we must reason over the final design if it fulfills our expectations and if it fulfills the requirements that we were given. In this case, I think we're fine because we imagine the application as that. I don't know if you're missing some. Okay, so are the lessons, yeah?
Maybe the rating field.
The rating, yeah. Where would you set the rating?
As an attribute of lessons.
Sure. Is it mandatory?
Maybe not.
Okay. But question, if we set the rating here, will we be able to know which rating did each user give to each lesson? I mean, is the rating something belonging, I mean, conceptually it is, no? Each lesson will have a rating. But how, we're missing still a relation between the users, between the students and the lesson. Because here we're just representing the relation between the tutors and the lesson. Okay, so here we can just express that a tutor will teach a lesson on a specific subject. But we are still missing one bounding. That is the one between the users and the lessons. So how do we add that specific relationship? One to many. One to many in the sense that one user can take many lessons, but each lesson which will involve just one user, right? So we already decided that we won't be offering group lessons. Are we fine with that? Okay. So in this case, okay, does this make sense? So that at some point the lesson is the point in which I relate a specific subject taught by a specific tutor and in which it is involved a specific student, okay? Is the way as I'm seeing that. So I have one entity that relates three other entities. The subject that is taught by a specific user and is taken by a specific student. Once again, this has restrictions. The way of designing this schema has restrictions. It has the restriction that the lesson is just for a single student, it's not for a group. It has the restriction that it is taught on just one subject, not on different subjects. And it also has the restriction that is taught by one tutor, not by several tutors. Yeah.
Isn't it better to do different students to, I would say, link more students to the same lesson? For example, many students are following the same lesson.
It's an option, but yeah, it's an option. But there is the question there. In our platform, are we going to let the users, different users, to make group lessons, or are we not going to allow group lessons? It depends. Yeah, it depends. It depends. We can agree on that. We can agree if we want to create a group lesson, or if we understand a lesson as a single tutoring between a student and the tutor. So the question is, which one do we want? Which one makes more sense in real life? I don't know how it works, like the tutoring sessions here. Have you ever been into one? Well, I don't know.
I think it can be both, but I would make just individual lesson.
An individual one. But for instance, let's suppose that case, that we want to enable the group lessons. What would change here?
We remove the AD tutors from lessons, the AD user from a lesson,
Yeah, this one, you mean?
and we put it, maybe it's better in a student table.
Or both. Okay, maybe a student table, but in that case, what happens if I do something like that? Users has lessons, and here I have ID, okay. Okay. What happens if I create this intermediate table? This is working as a many-to-many table, no? And in this case, I'm saying that a lesson might involve several users, and several users might be taking different lessons, okay? So in this case, we're building a many-to-many relationship. I understand what you say, like, why don't we create a separate students table? But in this case, the reason we didn't do that is because there is no specific data that a student has different from the data that a user has. You know what? So in the case of the tutors, it made sense because the tutor, other from this general information, has also a bio, and he also has different relationships with a lesson. We don't want a user to be related to a lesson. We want a tutor to have some relation to a lesson, for instance. So in that case, it makes sense to represent it as a different entity. In this case, if we try to split the users into students, which information are we going to add to the students table? Okay. We might think of something if we want our application also to represent the students' information, but as the specification is right now, there is nothing else to represent on the student side. Then if we let's suppose that if we want to enable like group lessons, this one would be the way of doing that, through an intermediate table that links the users to the lessons. So that a lesson might have several users or several students, and one student might take several lessons, okay? But, well, in this case, maybe it is better to keep it simple or to keep one tutoring session for one specific user, okay? So here the relation is one-to-many. One lesson has just one user, but one user can have many lessons. Okay, are the lessons going to be for free? They will have a price, right? Yeah.
We can put the hourly rate, and then depending on the time, we will compute the
Sure,
price.
sure, of course, I agree. So, and where do we set the rate?
Lessons.
The lessons, right? Because it's information that belongs to the lesson. So a lesson taught by a specific tutor on a specific subject has a rate. So in this case, it is here. Question. Here, do we need to and this one should be not null. Here, do we have to represent, or is it convenient to create a new field for saving or for expressing what is going to be like the total amount that I have to pay based on the rate and on the duration of the class? Sure. So the reasoning here is we want to represent that information because based on the data that we already have, is something that we can compute. So the rule also always with SQL is if there is information that we can compute based on the data that we already have represented, then we don't create a specific attribute for that. Or we don't store into a different field, okay? So this one is not necessary, okay? This one is also one-to-many, and okay, bring many on this side. And this one is also one. Okay, are we satisfied with our schema, with our database design? Are we missing something? Does it convince all of you? Okay. Once again, not here, we will leave this one as it is, but for the exam, when you will be doing your own database schema, the way of knowing or to get sure that it works and that it works is reading again the text And for each requirement or each specification in the text, try to figure out if, based on this data that you would be storing in the database, you can compute and you can calculate and you can provide all of the functionalities that the requirements are asking you to complete. So if with this schema I can represent the fact that the lesson have a price and I can compute what is the price for the number of hours that a specific tutor has given, then I'm fine. If based on this schema I can compute, for instance, a rating, an overall rating for a tutor, then I'm fine. So for instance, that one, is it possible based on this schema to compute what is the average rating for a tutor based on the rating that he has received for each lesson? Yes, it is possible because we already represented that field for a specific lesson. Each lesson knows what is the tutor that has taught that lesson, and each lesson has its own rating set by the users. Is it possible to compute based on this or to show based on this all of the history of the lessons that a specific student has taken through a platform? Yes, based on this, I can know all of the historical records of a user in our platform. If we were asked, for instance, in the application, if our requirement was, give me which are the most popular subjects, can we compute that? Are we able to know which are the subjects that have been taught the most? Yes. Okay. So, I don't know if we are fulfilling all of the requirements from the text that I showed you before, but my message, or what I want to convey, is that the way of getting sure that a database schema works is by comparing it to the requirements that have been given to us. Okay, so since we are happy with this schema, let's try to implement that. So let's get back here. Okay, so here I will create a database that I will call it Imparato. Okay, here we have our database. So the first table that we might be creating is users. In users, we said that it has an ID that is an integer, that is not null, is a primary key, is auto increment, and it is unique. As I told you before, even if I don't specify this unique and this not null, just because I have specified the primary key, it is implied, or is it by default also not null and unique, okay? Because the primary key has that specific condition and that specific nature that a primary key is not null and is unique. And here we set the auto increment so that each time the value grows, the number grows by itself, so that it is managed by the database and not by us. Okay. We have then the name, that in this case is a text, not null, and nothing else. We have the surname, that is a text, is not null, and nothing else. We have the email, and then we have the password. Okay, so this is the users table, and it has these attributes. Let's create the new table, that is the tutors. It will have the ID. It has the bio. And it has the okay. So here, important, I created this field as ID user, and it represents the foreign key that links me, the tutors or the tutor row, with the user. Okay. So here I create a field as ID user. I set it as an integer, as not null. And then for doing the bounding with the foreign key, you will observe that here we have the foreign key column. Okay. So by clicking here, when you click it here, it enables you to select to which field do you want to associate this foreign key that we are just creating. So in this case, we said that we want to associate it with users, and we want to associate it with the ID of the user. Okay. And here you can see, you can observe in this text area that it basically writes all of the SQL query necessary to create the table. Okay, so what I told you yesterday, indeed, what the browser gives us is like a graphical interface through which we can interact with the database. But at the end, what is really happening is that it is creating a SQL query that is being executed to create or to do any kind of operation over the database. So by executing this, we are creating the table. Okay. Then we have subjects. Ah. Okay, the rating here, do we set the rating as not null? Or do we, what do you think the rating for a specific lesson? Do we set that field as not null? Yeah?
I think it should be optional.
Okay, why?
First of all, the new. No, wait.
The rating. You know, like the rating that a user gives to a specific lesson, should it be null? Not null, sorry. What do you think?
Yeah, I guess there could be cases where not enough people give a rating.
Cases where the student don't give a rating to the lesson. Okay.
Maybe just a couple.
That might be a case, no? That the user don't want to rate a specific lesson. So in that case, it is better if it is not null. But there is another case that might be inconvenient if it is not null, and it is when creating the lesson, no? Because if I say that a lesson must have a field that is rating and it must be not null, then when the user wants to create a lesson, it will be forced to insert something in that field, no? And at some point, it doesn't make sense the lesson to have a rating. Okay, something. Okay, if we think of the interaction of the users with our platform, we would imagine the tutor creating his lesson with the time or publishing his lesson, and just after the lesson has happened, then the user will have the opportunity to rate that specific lesson. So in that case, we can't force the users, or we can't force anyone to set a value for that specific field, because the lesson hasn't already happened. Is it clear the reasoning here? So we won't force him to set a rating when creating a new lesson, but we will leave that field non-optional, so that just after the lesson has been completed, that field can be fulfilled. Okay, so in this case, it's not null. And in this case, with the price, is the price not null? I would say yes, no? Because when the tutor wants to create the lesson or publish the lessons that he's offering, he should be forced to set a price for the lesson he's offering. Okay. Okay, so here we have the attributes, and now we need to add the foreign keys. One of them is ID subject Okay. Okay, so we basically first did our diagram, and now we basically translate that diagram into the database, into the real database file here, the SQLite file. And here in the browser, you can see that we have this new folder that we have just created with our database and with the 4 tables that we have defined so far with their specific fields. Okay. So up to now, is everything clear? Is it clear all the process we have been following so far? Perfect. So let me just, okay, I think the last time we worked on Imparato was, yeah, it was last week. So let me copy the last version of Imparato. Okay, so if you want, let's make a break here, 15 minutes, and then we get back and start working on the implementation, okay? So let's stop